Alright, so today we are going to learn how to factor trinomials where that a value is bigger than 1. And what do they mean by that a value? So trinomials are terms or expressions with 3 terms, and they're in the form ax squared plus bx plus c. So far we've learned how to factor things that are like this, where the x is equal to 1. And if the x did not equal 1, we were able to pull out a greatest common factor. All right, but let's go ahead and look at this first one here. When I look at these, my a is not equal to 1. I have a 3. And then I don't have a greatest common factor. There's nothing I can pull out between 3, 2, and 5. They're actually all prime numbers. So there's nothing I can pull out. So I'm going to teach you how to do these. Now bear with me, they are tricky, but you'll pick up on it. So the first thing we're going to do is multiply the first and the last term. We get negative 15. Now you're going to go ahead and write out all the factors of negative 15. If you're having a hard time writing out the factors ever, I would always just start with 1 and work your way up. So is 1 a factor? Yes, it is, right? We can do negative 1 and 15. We could also do positive 1 and negative 15. Next, 2. Is 2 a factor? No, 2 is not a factor of 15, so we skip it. 3. 3 is a factor. We'll do negative 3 and 5, positive 3 and negative 5. Is 4 a factor of 15? No, it's not. So we'll go ahead, we'll go up to 5, which we already have 5 written down, which tells us that we're done. So now what we need to do is look at our factors and figure out which one of these is going to add to give us a negative 2. All right? That is going to be these guys here. Now this is the part where it gets a little bit different. You're going to write out the binomials here. Now normally you would just do p and p, right? Well, let's go ahead and try this. We're going to do a 3p and a 3p. Okay? Now, technically, when you do this right off the bat, it doesn't work, right? If you were to multiply this back out, you would get a 9p over here, 9p squared, which is wrong. But there's an extra step. So we do 3p, 3p. Then you have to look at these binomials and see which one you can factor out. Which one has the greatest common factor you can pull out? Well, these both have a 3 I can pull out. So I'm going to pull out a 3, and I'm not going to write it. I'm just going to take it out. So I get p plus 1, 3p minus 5. All right. Now, again, you can always check these to see if you did it right. You could FOIL, right? You get 3p squared minus 5p plus 3p minus 5. All right, and I get 3p squared minus 2p minus 5. All right, so the actual, I guess I shouldn't circle that because that's not my answer. My actual answer here, was this guy. So you have to make sure that you do that factoring out the greatest common factor and just getting rid of it. This is called borrow and payback. Let's do another one. I'm sure you're kind of watching me and you're like, oh, I don't know what she just did. So let's go ahead and try. All right, let's do this one. So we have an a value that is greater than 1. So, and we can't factor anything out. I look, is there anything I can factor out of 2, 11, and 5? There is not. So I'm going to go ahead and use my borrow payback method. I'm going to go ahead and multiply these guys. So I get 10. I'm going to write out the factors of 10. I get 10 and 1, 2 and 5. All right? So now we have to figure out which ones add up to 11. All right? So I've got, let me write out my binomials here. Sorry. So which ones are going to add up to 11? We got 1 and 10. So we're going to do plus 1, plus 10. And notice how I wrote 2v in both of these spots. So now we got to look. Can we pull anything out of these binomials? Well, I can pull a 2 out of here. So I'm going to get 2v plus 1, and then v plus 10, or I'm sorry, no, v plus 5. Right? Because you can pull a 2 out of there, and remember, you just get rid of it. Now, one way to make sure that you've factored properly is you could always kind of check to make sure that these first 2 terms are going to multiply to give you the first term up here, right? Let's say I forgot to take my greatest common factor out of one of the binomials. I would get a 4v squared when I FOIL, which is not what we want, right? So you have to make sure that you do that added step of taking out a greatest common factor from the binomials. All right, let's do some more. Let's try. Let's do this one here. All right. So first, I'm going to go ahead and look. Is there anything I can take out of all of these? No, there is not. So I'm going to go ahead and multiply these guys out. All right. So I'm going to do negative 30 times 2. That's going to give me negative 60. So now I'm going to write out my factors of 60. Now there's a lot of them. All right. We're going to do 1 times negative 60, negative 1 times 60. Then we've got 2 times negative 30, negative 2 and 30. 3 times negative 20, negative 3 times 20. 4 times negative 15, negative 4 times 15. 5 times 12. I'm sorry, 5 times negative 12. Negative 5 times positive 12. Then we get 6. Negative 10. Negative 6 and 10. 7 does not go into 60. 8 does not go into 60. And then 9 does not go into 60, which just brings us back to 10. So we've written out all the factors here. So now we got to go ahead and figure out which one is going to add to give us a 7. So you could go through, figure out what each one adds up to. This guy here is going to give me my 7. So I'm going to go ahead, set up my binomials here. I'm going to do 2r, 2r. But I know I'm going to end up having to factor one of these, right? So then I look, well, which one of these can I factor something out of to get my 2 front numbers to multiply to give me that? Well, I can take a 2 out of this second binomial. So I'm going to get 2r minus 5, and then r plus 6. All right. All right, so let's go ahead and try this one. This one's going to be a little bit trickier, but we can do it, guys. So again, we're going to go ahead and look, see if there's anything we can factor out. Is there anything we can factor out here? Unfortunately, there is no greatest common factor, so we cannot factor anything out here. So we're going to go ahead and do our multiplication things. We're going to do 6 times negative 49. That's going to give us negative 294. All right, and that's a big number. That's tough, right? But we can do it, guys. So let's go ahead and we're going to write out some factors. All right. So we've got 1 and 294. Right, so we can do negative 1 and 294, or we can do 1 and negative 294. We can do negative 2 and 147. 2 and negative 147. 3, does 3 go in there? Yeah, it does, right? We could do negative 3 and 98. Positive 3 and negative 98. 4 doesn't go in there. 5 doesn't go in there, but 6 does. 6, we could do negative 6 and 49. Or we can do 6 and negative 49. All right. Now, I want you to keep in mind, as we're going through these, we're interested in the factors that are going to add up to 7. All right. So far, none of these are adding up to 7, so I got to keep going. So let's try 7. So we would do negative 7 and 42. Or we could do positive 7 and negative 42. Again, not going to add up to 7, but that's okay. Let's keep going. So we can try 8. 8 doesn't go into it. 9 doesn't go into it. 10 doesn't go into it. 11 doesn't go into it. 12 doesn't go into it. 13 doesn't go into it. But 14 does. All right, we could do negative 14 and 21. Or we can do positive 14 and negative 21. All right, so let's take a look. Does that work? Right? Well, this guy's looking, this guy's looking pretty promising. All right, we could go ahead, add these up, and we get a positive 7. So those are going to be our numbers. Now this one's tricky, so follow along here. We're going to do our 6x plus 7. Or I'm sorry, goodness, 6x plus 21 and 6x minus 14. All right, now we need to take out our greatest common factor, right? So far, we've only had to take a greatest common factor out of one of these. But if we're looking, we're actually going to have to take a greatest common factor out of both of these. All right, I can take a 3 out of this guy, and I can take a 2 out of this guy. So I get 2x plus 7 and 3x minus 7. All right, and we can, of course, go ahead and check our answer, right? This is our answer here. Let's make sure that it works. We're going to do 2 times 3, which is going to give us 6x squared minus 14x plus 21x minus 49. So we end up with 6x squared plus 7x minus 49. That means it checks out, right? So we are good and happy. So to kind of reiterate, how did we do this? We went through and we found the factors that added up to 7. And then we had to take the greatest common factor out of these binomials. The greatest common factor of the first one was 3, and the greatest common factor of the second one was 2. Really, you always need to check and make sure that these two, when you multiply them, are going to give you this, right? Because 6x times 6x gives us 36x squared, which is no good. We want to... All right, so I'm going to do one more problem, one more example, and I'm going to go ahead and really break this one down. I'm going to go step by step and just go nice and slow. So, first thing we're going to look for is, do we have a greatest common factor, right? We look here, and unfortunately there is no greatest common factor between 7, 20, and 12. There is nothing we can pull out of there. So then the next thing we're going to do is multiply the first number and the last number. All right, so when I do this, when I do 12 times 7, I get 84. All right. Then what we're going to do is write out the factors of the number from part 2. If this is a big number, a challenging number, just start with 1 and go up. See, is 1 a factor, is 2 a factor, is 3 a factor, and you just keep going. All right, so if you have a hard time coming up with the factors, just start with 1 and work your way up. All right, so let's go ahead and do that here. Let's write out our factors. So for 84, we are going to have a lot of them. Now, one thing I want to point out, notice how this is a positive 84. It's going to have to add to give us a negative 20. All right, so as we write these out, keep in mind, we want these to add to give us a negative 20. So we're going to need both negatives. All right, so we're going to have negative 1 and negative 84. We could do negative 2 and negative 42. We could do negative 3 and negative 28. We could do negative 4 and negative 21. We could do negative 6 and negative 14. We could do negative 7 and negative 12. All right, So then we've written out all of our factors. I'm going to go ahead and just move those out of the way. Our next step is going to be to find the factor that find the pair of factors that add up to give you that middle number. So now we need to go ahead and look at our factors. Our middle number is a negative 20. All right, which one of these are going to add up to give us a negative 20? That's going to be this negative 6 and negative 14. All right, so now the next step is going to be to write them as a binomial. With the first term up front. All right, so what do I mean by that? You're going to do 7p, then we're going to do minus 6, then we're going to do 7p minus 14. All right, then the next step is factor out the greatest common factor out of one or both of the binomials. All right, so I look at these. I don't have a greatest common factor of 6 and 7, but I can pull a 7 out of 7p and negative 14. So I'm going to get 7p minus 6 and p minus 2. All right, so basically when you factor that out, you just kind of get rid of the GCF. You don't write that one. All right, and kind of a checkpoint here would be to make sure that these two numbers multiply to give you first term. All right, so check to make sure the first two numbers multiply to give you the first term of the trinomial. Wow. And so that would be here, 7p times p is going to give us 7p squared. So that checks out. And that right there is